Alright, what's up everybody? We're back, and this time we're going to talk about finding the function given a graph. So function given a graph. So in other words, we have to determine what a function is of least degree from this graph that I have for you guys. So first things first, in order to do these problems, we have to identify the x-intercepts. So here I am, I'm going to put them in red so that they're nice and visible. We have one at -2, we have one at 1, and we have one at 3. So those are our x-intercepts. So I'm going to say that f of x, hold on, let me reduce the thickness of the pen. I'm going to say that f of x is going to equal some number a times the first one we have, right? We have x is equal to -2, which means that the factor is going to be x plus 2. Because if I plug in -2 in here, I get 0, which is what we have right here, right? If I plug in -2, I get 0. So you actually take the opposite of what you're given. All right. The next one I have is x is equal to 1, which means that my factor is going to be x minus 1, right? And the last 0 or root that I have is x is equal to 3, which means that my factor is going to be x minus 3. Because if I plug in all of these, my function here becomes 0, which is why they're called zeros. Right? There's a method to the madness of the naming convention that mathematicians chose. Now, I don't know if this graph is scaled, if it's scaled or not, right? So I have this arbitrary constant in the front, a, and I'm going to put it in green right here. I have this number a. I don't know what it is, but we can find it given another point from the graph. So what point do we see that we can use? We can use this point right here, the y-intercept, because the coordinates for that right here, for this point right here in red, the coordinates for it are 0, 3. Those are the coordinates for that point. So when x is 0, y has to be 3. So I'm going to use that fact. All right? So when y is 0, when x is 0, y has to be 3. So here I go. So 3 is equal to some number a, you don't know what it is, times, well, x is 0. So it'll be 0 plus 2 times 0 minus 1 times 0 minus 3. Just like that. And we can keep solving this to find what our a value is. So now I have 3 is equal to a times 2 times -1 times -3. Let's keep going. 3 is equal to a, well, 2 times -1 is -2. -2 times -3 is positive 6. Right? Negative times negative is positive. So we end up with a positive 6. So now we have to divide by 6. And we finally get our a value. A is equal to 3 over 6. But that reduces to 1/2. So our final function, and I'm going to put it in this box right over here. Our final function is f of x is equal to 1/2 times x plus 2 times x minus 1 times x minus 3. And that's it right there. I'm going to graph it so that we can verify our answer. All right, here we go. So I have 1/2. And our first one was x plus 2 times x minus 1, x minus 3. X minus 1 times x minus 3. Boom. And now let's compare this one with what we were given, okay? So let's check it carefully. Here, we're going to put it side by side. Let's compare it. We have the same x-intercepts right there, right there, and right there, and right there. It looks very, very spot on. And in fact, we could even check 2, negative 2, it looks like, and it looks like it's not exactly 2, negative 2, this one I'm pointing at, but it's pretty dang close. So there we have it. We got it right. So that's how you do that. All right, so let's do the next one now. We have a few problems to go over so that everything becomes clear. So that's our first one. Let's do the next one now. Here I have, how many roots do we have to choose from? Right? I'm going to highlight them so we can see them. Let's highlight it in red. So we have one root here. Oh, you can't really see that. Let's do it in red. We have one root there, one root there, and one root there. So we're looking at a minimum of a third degree polynomial, right? Because we're given 3 roots. So our roots are given as x is equal to negative 3, x is equal to negative 1, and x is equal to 3. Cool. So now, oh, and we have the y-intercept right here in green. We have it. And our y-intercept has the coordinates 0, 2. So y-intercept as 0, 2. We're going to use this to find the scale factor if it's not 1. We can't assume it's 1. It might be 1, but we don't know. So now we're ready to write our function. So our function f of x is going to equal some number a, right, times x plus 3. That means we need x plus 3, right? Because it's a minus, so we need to make it plus to make it 0. And x is equal to negative 1, which means we need an x plus 1. And x is equal to 3, which means we need an x minus 3. Just like that. So far so good? So far so good. Now we're going to use our y-intercept to find out what our a value is. So when x is 0, y is 2. So we have 2 is equal to some number a times 0 plus 3 times 0 plus 1 times 0 minus 3. Just like that. And let's reduce this further. So 2 is equal to some number a times 3 times 1 times negative 3. That means that 2 is equal to some number a times 3 times 1 is 3. 3 times negative 3 is negative 9. And let's divide by negative 9 on both sides, which means we get a is equal to negative 2/9. So a is equal to negative 2/9. And this fraction is fully reduced, so we can't reduce it. Alright, so now let's finish drawing our function. Alright, here we go. Let's do it. So our final result is going to be f of x is equal to negative 2/9 times x plus 3 times x plus 1 times x minus 3. Just like that. And let's graph it again to verify our answer. Alright, let's remember what it looks like. Cool. So it's going to be negative 2/9 times, what was the first one? It was x plus 3, x plus 1. So x plus 3 times x plus 1. And the last one was x minus 3. Oh, I drew. What the heck is going on? Oh, let's try again. Sorry about that, guys. Technical difficulties. So it was x plus 3 times x plus 1 times, what was it again, the last one? X minus 3. X minus 3. Alright, it looks pretty close to what we have. So let's check our roots. Negative 3, negative 1, 3. Negative 3, negative 1, 3. Cool. So roots are correct. And let's check our y-intercept. 0, 2. 0, 2. And there we have it. So we're using factors, the zeros, to create our graphs. This is why it was important in the previous video to factor out a graph, because we can get where the roots are, and from there we can know how to build our graphs, okay, if we're not given it. So we're basically working backwards. Let's do our next example. This one's tough. The other ones we can clearly tell what degrees they were, but this one's a little tougher, right? From the previous video that I posted, we know that we have 1 degree here, so that's one factor, and then we have this one right here. But keep in mind that it ricochets. You see how it hits it and bounces up? That means that this negative 1 is a double root. So we have 2 roots. X is equal to negative 1, x is equal to negative 1, and x is equal to 2. Alright? This one right here is a double root, which is why I wrote it twice. It's a double root, which means we can now find the y-intercept, which is at y-intercept is at 0, 2. So now let's write our polynomial. Alright? So it looks like it's going to be minimum a 3rd degree. So let's write it. So we have f of x is equal to some number a times the factors. I'm going to keep it in red so we can see them better. You know what, since these two are shared, I'm going to keep them both red, but since the last one is a different one, I'm going to change the color on it. So this one's going to be x is equal to 2. So that way we keep track of our roots. So x plus 1, right, because it's negative, another x plus 1, and now we have x minus 2, just like that. Now we're going to use the y-intercept to find out what our a value is. So 2 is equal to a times zero plus 1, right, times 0 plus 1 again, times 0 minus 2. Just like that. So now we can finally start breaking down this polynomial even further. So we get 2 is equal to a times 0 plus 1 is 1, 0 plus 1 is 1, 0 minus 2 is negative 2, which means that 2 is equal to a, 1 times 1 is 1, 1 times negative 2 is negative 2, right? So now we're going to divide by negative 2 on both sides, which means that our a value is actually negative 1. That's our a value. So now we're ready to write our polynomial. So let's write it. That means that our function of least degree for this graph is the following. F of x is equal to negative 1 times x plus 1 times x plus 1 right, times x minus 2. Just like that. And you'll notice that x plus 1 is repeated. So I'm going to rewrite that so that we're using exponents. And this time I'll put it all under one color. That means that our function f of x is equal to negative 1 times x plus 1 quantity squared times x minus 2. And that's our function. X negative 1 times x plus 1 quantity squared times x minus 2. And let's graph it again just to verify it. It was negative 1 times x plus 1, right? Yes. X plus 1 quantity squared times x minus 2. So this is what we have. Let's check it. It crosses at negative 1 and 2. It crosses at negative 1. It bounces up and 2. Cool. We got the double root correct. And 0, 2. 0, 2. Look at that. Pretty cool. Alright, next one. I hope this is getting clear, guys. But they will get a little bit more challenging. So here we have another what looks to be a double root, right? You guys see it? We're going to pick a different color now. Let's go with purple. We have a double root right here and a double root right there. So right there and right there. Okay? So now I'm just going to write it. F of x is equal to some number a times x plus 2 quantity squared, because it's a double root, so I can square it, times x minus 3, just like that. Cool, cool, cool. Now we got to figure out what our a value is by using this point right here, 0, negative 3. So when x is 0, y is negative 3. F of x is negative 3 when x is 0. So a 0 plus 2 quantity squared times 0 minus 3. Let's keep going. Negative 3 is equal to a times 2 squared times negative 3. Negative 3 is equal to a times 4 times negative 3. Before I even multiply, I'm going to divide by negative 3 because I noticed that they share it. So these negative 3's go away. Any number divided by itself is equal to 1. And then we have a times 4. Divide by 4. Divide by 4. That leaves us that a is equal to 1/4. So now we can write our final equation. Here it is. Our final equation is now f of x is equal to 1/4 times x plus 2 quantity squared times x minus 3. There's our answer. Let's go to the next example. Whoa. How many degrees do you guys think this is? Let's count them. Alright. Let's do them in red so they're very visible. We have 1, 2, 3, 4 roots, which means this is a 4th degree polynomial. And then we have the y-intercept right here also in red at 0, negative 3. So we're going to use all these facts to help us build a function for this polynomial. So f of x is equal to a times x plus 3 for the first root from left to right, x plus 2 times x minus 3 times x minus 4, just like that, just like that. And now we can plug in our known values, this known point, so that we can find out what our a value is. So when x is 0, y is negative 3. So the function value is negative 3 when x is 0. I'm plugging 0 for x, and I'm just skipping the arithmetic because we know that 0 plus 3 is equal to 3. And then negative 3 here, and then negative 4 here. Okay, let's do some math. Negative 3 is equal to a times 3 times 2 is 6 times negative 3 times negative 4. I see that they share a negative 3, so I'm just going to divide by negative 3 without multiplying, so I can get rid of it quickly. So that goes away, and this becomes 1. So 1 is equal to a times 6 times negative 4, which means that 1 is equal to a times negative 24, which means that we divide by negative 24 from both sides. Then our a value is equal to negative 1 over 24, just like that. Cool. We're now ready to write our final equation for our function. So that means that our final one is f of x is equal to negative 1/24 times x plus 3 times x plus 2 times x minus 3 times x minus 4. There we go. If you want to expand it, go ahead and expand it. I don't want to because that's a lot of work, but this is equally valid. All right. In fact, this is probably more useful because it tells us what the roots are in the graph. If we're not given the graph, this is a lot more useful because it tells us the roots. Let's graph it and verify our answer. So negative 1 over 24. It was x plus 3 times, what was it? X plus 2. And then the other one was x minus 3. And then was x plus 4, I believe. Yeah, x minus 4, sorry. X minus 4. There we go. All right, let's check it. Boom, 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 boom. Yep. And then let's check our y-intercept, and we're golden. Look at that. 0, negative 3. Exactly like this graph. Cool. Let's do another example. Oh, that's our last example. So I hope this clears it up, guys. This is why factoring is very useful and how using the factors can help us find the equation for the graph. So feel free to ask questions, guys. Feel free to leave comments. If you need more practice, more exercises, I'll be happy to develop some more, and we'll take it from there. All right, guys, catch you later.